Let's start with a confession. Milk used to be boring. It was just milk, white, cold, quiet, something you poured on cereal and forgot about. Then suddenly, milk became controversial. One day it's nature's perfect food. The next day it's white poison. Some people say milk builds strong bones. Others say it causes cancer. Some say it's essential. Others say humans were never meant to drink it. And somehow, everyone sounds confident, which should immediately make you suspicious. Because when a single food is blamed for cancer, weak bones, acne, inflammation, early death, climate change, and the collapse of civilization, something strange is happening. So today, we're not here to defend milk, cancel milk, or tell you what to drink. We're here to do something much rarer. We're going to understand milk, where it came from, why humans started drinking it, who it helps, who it hurts, and why the same liquid can be a survival tool, a health food, a problem, and a moral dilemma, all at the same time. This isn't a milk good versus milk bad video. This is a biology plus evolution plus modern reality video. So grab a glass of whatever you drink, and let's talk about the most misunderstood liquid on Earth. Number 1. Milk is not normal food. Let's strip away marketing for a moment. Milk is not just something to drink. Milk is a biological instruction manual. Every mammal produces milk for one reason: to build a body fast. Not slowly, not gently, fast. That's because newborn mammals arrive unfinished. Their immune systems are immature. Their organs are underdeveloped. Their brains are still wiring themselves. Milk solves this problem by delivering concentrated biological signals, not just calories, instructions. Milk contains fats for rapid tissue expansion, proteins for muscle and organ construction, sugars for immediate energy, minerals like calcium and phosphorus, immune compounds that actively shape immunity, hormones and growth factors that tell cells when to divide. Milk doesn't whisper. Milk shouts. From a biological perspective, milk is closer to a developmental drug than a neutral food. This is why babies grow absurdly fast. A human baby doubles its weight in months, triples it within a year, builds a brain faster than at any other time in life. Milk is the fuel that makes that possible. And here's the crucial part. Milk is designed to be temporary. In every wild mammal, milk ends when teeth appear, digestion matures, movement improves, solid food becomes possible. This is not a cultural tradition, it's biology. Milk exists to bridge a gap, not to be a lifelong staple. For over 95% of human evolutionary history, adults did not drink milk. They couldn't, they didn't need to. Their bodies weren't built for it. So when people ask, were humans meant to drink milk? The honest answer is yes, as babies. Everything beyond that is adaptation, not design. Then humans did something wild. About 10 to 11,000 years ago, humans broke the rule. They stopped roaming constantly. They built permanent settlements. They domesticated animals. And one day, someone realized something revolutionary. You can drink milk that isn't yours. This was not obvious. Drinking another species' bodily fluid is weird. But survival has a way of lowering standards. Dairy animals had a unique advantage. They could eat grass, something humans couldn't digest, and turn it into dense nutrition. That meant food during drought, food during winter, food when crops failed. Milk became a calorie backup system, not luxury,
not wellness, survival. And in a world where starvation was common, that mattered more. This is where evolution stepped in.
Number 2. Lactose tolerance, evolutionary cheat code. To understand the milk debate, you must understand lactose. Lactose is milk sugar. To digest it, you need lactase, an enzyme produced in the small intestine. All human babies produce lactase. Without it, breast milk would be useless. But here's the default mammal setting. After weaning, lactase production shuts down. No enzyme, no milk digestion. This is true for wolves, lions, cows, chimpanzees, humans originally. Lactose intolerance is not a disorder. It is the ancestral condition. Globally, about 65% of adults lose most lactase activity. That's the majority of humanity. So why can some adults drink milk with zero problems? Because of one of the most fascinating examples of gene-culture co-evolution ever discovered. In several human populations, independently, random mutations occurred that kept lactase production switched on into adulthood. Normally, random mutations fade out, but these didn't. Because in dairy farming societies, lactase persistence gave people more calories, more protein, better survival in famine, higher fertility, healthier children. Those people lived longer. They reproduced more. Their genes spread. This happened in Northern Europe, in parts of East Africa, in Middle Eastern pastoral societies. Not once, multiple times. Same solution, different places. Evolution saw milk availability and said, fine, we'll adapt, but only partially. That's why today, Northern Europeans have high lactose tolerance. Southern Europeans have moderate tolerance. East Asians often have very low tolerance. African populations vary dramatically. Milk tolerance is a map of human history. Your ability to drink milk tells a story about your ancestors, their climate, their survival strategies. Milk didn't become universal, it became selectively useful. Why lactose intolerance feels so bad? When lactose isn't digested, it passes into the colon. Gut bacteria ferment it. Gas, bloating, cramps, and diarrhea follow. This is not poisoning, it's microbial chaos. Your gut bacteria are throwing a party you didn't approve. This is why symptoms vary. Some people feel mild discomfort, others feel intense pain. Some tolerate small amounts, others tolerate none. Lactose intolerance is not the same as milk allergy, immune reaction, casein sensitivity, or whey intolerance. Those are different mechanisms. Many people who hate milk aren't reacting to lactose at all. They're reacting to milk proteins. Which brings us to the next layer of complexity. Milk is not one thing. Milk is a biological cocktail. It contains lactose, sugar, fat, casein protein, whey protein, hormones, growth factors. Different people react to different components, which is why lactose-free milk helps some people, but not others. Fermented dairy helps some, but not others. Milk tolerance is not binary, it's individual. And modern milk complicates things even more. Modern milk, not ancient milk. The milk your ancestors drank came from smaller animals, with seasonal production, lower yields, different protein ratios. Modern dairy cows are biological machines. They produce far more milk, with higher growth signaling content, year-round. This matters because milk isn't just calories, it sends messages, which leads directly to hormones, metabolism, acne, cancer fears, and weight gain, the most controversial part of the debate. Number 3. Milk, bones, and the calcium paradox. Let's talk about the claim everyone has heard. Milk builds strong bones. This idea is so deeply embedded that questioning it feels almost illegal. Milk cartons, school lunches, public health posters, doctors' offices. Calcium equals bones, milk equals calcium, therefore milk equals strong bones. Simple. Too simple. Because biology is never that clean. Calcium is necessary, but not sufficient. Yes, calcium is essential for bones. No calcium equals weak bones. But here's what almost never gets explained. Calcium alone does not build bone. Bone strength depends on vitamin D for absorption, vitamin K2 for directing calcium, magnesium for structural balance, mechanical load, movement and impact, hormones, especially estrogen and testosterone. You can drink all the milk in the world. If these systems aren't aligned, calcium won't end up where you want it. In fact, excess calcium without proper regulation can end up in blood vessels, in kidneys, and soft tissue. Strong bones are not about intake, they're about distribution. What the large studies actually show. When scientists looked at milk consumption and fracture risk in adults, the results were underwhelming. Large observational studies found no clear reduction in fracture risk, sometimes no association at all, sometimes even higher fracture rates in high milk consumers. This shocked researchers. This doesn't mean milk causes fractures, but it does mean milk is not the magic shield we were promised. Why childhood matters more than adulthood. Here's where nuance matters. Milk seems to help during growth. Children and teenagers are building bone rapidly, have high growth hormone levels, absorb nutrients differently. But once adulthood is reached, bone maintenance becomes a different game. Movement matters more than milk. Hormonal balance matters more than calcium intake. Milk is not useless, but it is overcredited. Bone is alive. Bone is not stone, it's living tissue. It constantly breaks down and rebuilds. The strongest signal for bone growth is not calcium, it's force. Walking, running, lifting, jumping. Your skeleton responds to stress. No stress equals bone loss, which is why astronauts lose bone density in space, despite perfect nutrition. Milk can't replace movement. No food can. Number 4. Milk as a hormonal signal. This is where controversy lives. Now we reach the part where the internet starts yelling. Hormones. Milk contains hormones. Milk affects hormones. Milk messes with growth pathways. Some people panic, others roll their eyes. Let's slow this down. Milk is designed to activate growth. Milk exists for one job: make a baby grow fast. To do that, milk activates insulin, IGF-1, insulin-like growth factor 1, mTOR, a growth and nutrient sensing pathway. These are not bad things, they are essential. Without them, muscles wouldn't grow, wounds wouldn't heal, children wouldn't develop. But like everything in biology, dose and timing matter. IGF-1, the center of the debate. IGF-1 is a hormone that promotes cell division, inhibits cell death, supports growth and repair. Growth versus cancer. Same pathway, different context. Cancer is uncontrolled growth, so any signal that promotes growth gets side-eyed. Some studies found correlations between very high dairy intake, elevated IGF-1, and slightly increased prostate cancer risk. Other studies found no association, or even protective effects for colorectal cancer. Meta-analyses, studies that combine many studies, generally conclude
Moderate milk consumption is not strongly linked to overall cancer risk. Very high intake may increase risk for specific cancers in specific populations. Translation: milk is not a carcinogen, but it is not biologically neutral either. It pushes growth pathways. That can be good or bad depending on genetics, age, total diet, lifestyle, baseline risk. Acne, insulin, and modern diets. One area where milk's hormonal effect is very visible: acne. Multiple studies show skim milk increases acne risk, especially in adolescents. Why skim milk? Because removing fat increases whey protein concentration, insulin response, and IGF-1 signaling. Milk plus high sugar diet and sedentary lifestyle is very different from milk plus manual labor and low-calorie intake. Milk didn't change, the environment did. Warning: what about added hormones? Yes, milk contains hormones, but levels are extremely low. Most are broken down during digestion, and regulatory limits are strict in most countries. But milk also does not guarantee health, prevent disease, build perfect bones automatically. Milk is a tool, not a villain, not a savior.
Number 5. Milk, the planet, and the cost we don't see. Up to now, we've talked about biology, bones, hormones, digestion, cancer risk, metabolism. But milk isn't just a biological product, it's an industrial one. And this is where the conversation gets uncomfortable. Because even if milk were perfectly healthy, even if it caused zero harm to humans, there would still be a problem. Milk is not natural at scale. One cow does not destroy the planet. Millions of cows do. Modern dairy production requires vast amounts of land, enormous water consumption, constant feed production, transportation, refrigeration, processing infrastructure. Globally, about 1/3 of all cropland is used to feed animals, including dairy cattle. That land could grow grains, legumes, vegetables, forests. Instead, it grows feed. This is not because cows are evil. It's because converting plants into animals into milk is biologically inefficient. Greenhouse gases and milk. Dairy contributes roughly 3 to 4% of global greenhouse gas emissions. That may not sound huge until you realize it's more than all airplanes combined. It doesn't include indirect deforestation. Methane from cows is far more potent than CO2. Methane traps heat 80 times more effectively than carbon dioxide over short timescales. Even as dairy becomes more efficient, the scale keeps growing. Efficiency can't outrun volume forever. Water and resource use. Producing 1 liter of cow's milk requires hundreds of liters of water, both direct and indirect, feed irrigation, animal hydration, processing cleanup. In water-stressed regions, this becomes a serious ethical question. Milk is nutritious, but is it the best use of limited resources in a warming world? That's not a scientific question. That's a societal one. The ethics, the part most people avoid. Now let's talk about the part people argue about emotionally: animal welfare. Milk does not come from happy cows wandering freely forever. A cow only produces milk after pregnancy, which means repeated impregnation, repeated separation from calves, years of lactation, eventual slaughter. This is not opinion, it's how milk works. Some farms are better, some are worse, some are horrific. But industrial milk requires industrial systems, and those systems involve suffering. You don't have to become vegan to admit that.
You just have to be honest. The real danger is simplistic nutrition myths, fear-based health claims, ignoring trade-offs. Biology is complex. Health is contextual. Food is political. Milk sits at the intersection of all three.
Thanks for watching Cool Dude Explains, where comedy meets curiosity. Don't forget to like, subscribe, and drop your favorite myth or question in the comments. Stay curious, stay cool, and I'll see you in the next video.